All right, so lecture 10 is really our last formal lecture. We've covered assumptions and measures of central tendency. Now we're going to be covering a little bit more about how to do data analysis. So one of the first things to look at when you're looking at your data graphed out is, does the client's problem operationally defined increasing or decreasing over time? And if there is a trend, what can we do with that? Because we can't really report the mean or the median alone. So here we have a negative decreasing trend, because we can see the plus and the negative sign are flipped here. Here's the same thing, a positive decreasing trend, because the plus and the negative sign are flipped. But what can you do with that? Because you can't report the mean or the median. What you can do is report the acceleration line. So the acceleration line technique is essentially taking the moving average across different observations to give you an idea of what the trend would continue like if you were to keep moving on with the observation. So acceleration line can be used to describe patterns in data with more precision than just visual analysis. So trends can be accelerating or decelerating. And so statistically, acceleration lines connect the midpoint of the first and the second halves of the phase. So I'm going to be posting up an example online of how to go about doing this, and I think it'll make more sense when you actually try to do it yourself. So please look at the acceleration line hand exercise, because I think it's really going to help put this in context for you. And so again, with that exercise, if there are any outliers, as opposed to doing the mean, you would use the median. So again, anytime there's any outliers in any data, you would want to be using the median as opposed to the mean. So what can we say about this one? So this is the number of cigarettes smoked per day. And during the baseline phase, it looks like there's a negative trend, right? So it looks like their smoking was going down. But with the intervention phase, we could see that there was an accelerated rate of change. So compared to the baseline phase, where there was a negative decreasing trend in the amount of cigarettes smoked per day, during the baseline phase, this rate of change was accelerated. So there was an accelerated rate of reduction in the number of cigarettes smoked per day for this client. And we might not have noticed that without the acceleration line here. And this is another example of why collateral contact is so useful here. So for John's example of number of money spent gambling per day or per week, we could see that John's report is during his baseline, his spending was going up. And during his intervention period, there was a negative decreasing trend. But his collateral's report was thinking that his spending was going down during the baseline phase. But the intervention phase was really only associated with the accelerated rate of reduction in the number of money he was spending gambling. So here we have slightly different stories. And as a clinician, when you're seeing this incongruity, then you can kind of point this out and try to make more sense of it and when you're meeting with your clients. All right, so just a few more things. The 3 standard deviation band approach is used to detect statistical change from one phase to the next. So specifically, the approach can be used to determine whether a specific point is outside of statistical significant range. So again, with behavioral measures, we can look at what was going on with our behaviors and figuring out what the mean is and what the standard deviation is. And that predicts how unlikely a behavior would have changed without chance alone. So again, with this 3 standard deviation band approach, we can see if there's been a statistically significant change between any points from the baseline. So this is an example from Singwin. During our baseline mean, we can see it's 2.67, and our upper control limit is 1 standard deviation above, or rather 3 standard deviations above the mean, and lower control limit is negative 2.23, which is 3 standard deviations below the mean. And so none of these points are above or below the lower control limit, so there's no statistically significant change from baseline to intervention. And if you want to think about this from the normal curve, if you just flip this on its side, we can see that the lower control limit is 2 standard deviations below the mean, or 3 standard deviations below the mean, and the upper control limit is 3 standard deviations above the mean. So you can see that where this line would intersect with the normal curve. And so when you would use the standard deviation band approach is if your data doesn't have a trend and your data isn't autocorrelated. So again, for projects, this is something that you're not really going to be using too often, but just so that you're aware of how to do this, and this will be one of the Singwin exercises that we'll look at. So you'll be doing this with your data. But what you're going to be more likely using is a t-test. So a t-test tells us whether or not there's been a statistically significant difference between the mean and the baseline, or rather the mean score between the two phases, between the baseline and the intervention. So before you conduct a t-test, you have to make sure that your data isn't autocorrelated, obviously, and it's recommended that there's at least 6 data points. But when you're doing a t-test, how would you know it's statistically significant? And again, this will be in the Singwin activity. But if you do a t-test and your p-value is below 0.05, the magic number, that would tell us whether or not that change would have occurred by chance alone. So if you've got a p-value below 0.05, that couldn't have occurred by chance alone. We can show that statistically. So that would be a statistically significant change in the behavior. And again, just so you know the difference between statistical significance and practical significance, statistical significance is a systematic difference in a client's problem under a different condition. Versus practical significance is an improvement that's been made from the client's perspective. So sometimes you might report a practical significance. Let's say you're working with somebody who is on the autism spectrum and they've made some type of improvement in their social skills that maybe didn't reach the level of statistical significance. Maybe they didn't make enough new friends or have enough positive social interactions to be statistically significant. But what we know about autism spectrum is that it's really challenging for people who are on the spectrum to make friends or to have social interactions. So any kind of change that's significant to them could be something that reaches a level of practical significance, and that's something that's worth celebrating in itself.